Sir,
to
in which
cap.
use cases will be using timer, sir? In which use cases, as the embedded programmer, we need to, while designing the things, we need to take care.
So is your question when to use timer?
Yes, sir. For example, if we have got any application,
Hmm.
so we need to
Okay.
design the things. So at that time,
Okay. Let's say I can give this example, which is more straightforward and we have experience in that. We want to transmit a CAN packet every 250 millisecond. You can use timer not because it can count 250 count it can do. Right. Based on the count value that you upload, it can create a 250 millisecond delay. So when the timer not expired, you can create a timer not interrupt. When that interrupt occurred, you can transmit one packet, one instant of the packet. Once after that, again after 250 millisecond, again another timer interrupt will happen. That means overflow will happen, that will create an interrupt. So when the interrupt happens, you can transmit another packet. This is a periodic transmission of CAN packet you can achieve using timer. That is one thing. Another one, you have a wheel count which is coming from your wheel sensor. You need a counter. How many pulses has come per second? Based on that only you can compute your vehicle speed. Wheel count per second right now. Each rotation it will generate a pulse. Right, number of pulse per second will give you the vehicle speed.
yes, sir.
Right now. So in that time you can use timer not as a counter. Wheel counting. Right. Another thing, you have some sort of object identification algorithm or something like that. When particular object is detected, one count will be increased. So it is a physical, when there is a object detection, it will create a glitch in the camera output, which means that there is a detection in the object. There is an object detected. So you can give that to timer not to count how many objects you have detected. So like that, there are many use cases we can arrive for this usage of timers. You can use this timer to make task switching. Semaphores, if it is an R task, you can use them for making a task switching. Like that, we have many use cases for timers. And then we have something called a trip computer in cluster car meter right now. How long you have traveled and how much kilometer you traveled right now. To find out the trip amount of distance that you travel, you need again a wheel count. Only based on that only this much of distance you have traveled. Odo count. You have to count the Odo rollover. Based on that only you can say this much distance you have traveled. That becomes a trip computer value. So like that you can use this circuitry in different places, depends on your application and project need right now. So that is the use of the timer. That's why we have a timer in microcontroller.
I'm sorry, I had doubt. So timer 0 can be used for only one application, or at the same time we can use for multiple application.
Okay, brilliant. This question is, if a timer is engaged and with certain configuration, you can use it only with that song. So only you can use it for the application which require that configuration. If two applications has the same configuration, then you can use same timer to for those two tasks. Let us say I have two CAN messages in my microcontroller in my product. Both are transmitted at 100 milliseconds periodicity means I can use one timer to transmit them both. Right. So because their periodicity is same. If that is the case, I can use. But I have one CAN packet which is going at 100. I use timer not for that. Another CAN packet which is going at 250 milliseconds. Can I use a timer not for that? No. Got it now. So timer create a delay based on the configuration that you made. Right. If the task or application that is using the timer is having the same configuration, yes, obviously we can use them, no problem. If there is a difference, they have to go for different one. So actually they will group the tasks which are having the same configuration and will dedicate one timer for that. Like that they will go for. Okay, you use a timer. You require a timer only for some particular stages to get particular inputs from the environment. After that, you don't require the timer at all for a particular task. Then that task can release that timer so that others can use, other tasks can use. So because these are hardware, these are not software. These are present as a logical circuitry. So if it is available, anyone can use it. If one is using it, others cannot use that. Meaning that others with a different configuration cannot touch that one. That is not possible.
And sir, here I had a doubt. So in our automotive context, we will have CAN message with different timings like 100 millisecond, 200, 1 second. So
Yeah.
in those cases, if all the timers are engaged with CAN message, do other applications won't use the timer at that time?
Brilliant. Super. Thanks for this. See, they used to maintain internal counter. See, I have some 10 messages. Those are running at 100 millisecond. Another 10 messages, those are running at 200 milliseconds. Right. What I can do is I can use the same timer, 100 millisecond timer. I can configure, I can make it to run at every 100 millisecond. When I want to transmit 100 millisecond CAN messages, when the timer is expired, I will transmit all those 10 CAN messages. Perfect. Because their periodicity is 100. What about the 200 millisecond CAN messages? I will just maintain a counter. I will increase the counter by 1. Then next time 100 milliseconds over. Now the counter value is 2. When the counter value is 2, I will transmit a 200 milliseconds messages. When the counter value is 2, that is at that time also the 100 millisecond message will go. So in the CAN trace, when you see, you will see the CAN messages, those are 200 milliseconds once coming at 200 milliseconds once only. But internally in a microcontroller, they come to that timer event every 100 milliseconds, but they are not transmitting it. They update the internal counters. Like right now, because if we dedicate one set of microcontroller, one set of timers to one microcontroller, one timer to one CAN message means we have 100 CAN message in a product right now. So we need to have 100 timers then. Do you understand what I am trying to say?
Yes, sir. We'll be having internal counters.
Internal counter. So they will measure, okay, they will run the timer at the minimum periodicity of any one CAN message. The group of CAN messages which is having a minimum periodicity. No, in that periodicity they will run the timer. For others, they will maintain internal counters. So when the counter values reach, they will send them out. So like that, with the available timer, we can manage. No problem. If we can do many things like that. That is how the computer world works. or embedded system bulbs. Otherwise, they cannot dedicate one timer for one CAN message. That is not practically possible.